would be suitable. The ASV was asked to give its expert opinion. Unfortunately, we had experts in two camps, and that led to confusion. We selected from the Canada proposal, I believe it is, the segmented mirror, much like what we've got at the ONDSS on our footage. So it's a two elements separated by columns of glass. This is a lot lower mass, which has to be compensated for, because the original mirror is speculum. Now that weighs a ton, and this one is what would be better. All with that? Jim?
Yeah, probably. Incidentally, I've got some pictures which there's only 4 of them.
All right.
That's it.
Perhaps we can do that now.
Yep, right.
Did you want to speak to that, Jim?
No.
Okay. Then look at the pictures wrong.
Wow,
What size is that?
Not sure what size that there.
There you go. Never got the scope. That's all of it.
Okay, so that's basically what it's going to look like. It's not like that, that's like that one.
Yes.
Museum Victoria made it quite clear that the decision was theirs. They knew that there was merits in selecting either. Three of us sort of thought that Zurdu would be great, but the real downside with Zurdu, which if the museum is flush with funding, I don't think there would have been a problem. We would have gone with Zurdu. But we aren't flush with funds, and if we had gone with Zurdu, we would have expended all of our money, which meant other parts of the project may have been held up because we didn't have the money to help them. Still, we hope that we won't have any issues. There's still some doubt as to the mass, what that's going to do when we add the extra mass behind the mirror, take up the extra space is needed to balance the tune. But I'm sure that we've got some smart people in the ASV that can come up and solve that. The second thing that I would like to say is the Messier Star Party. Stuart, were you going to say something on that later? No? Is it you? That's on this Saturday. So if you want to go up, observe the Messier objects with other people, other viewers, please go up, enjoy the festivity, and it should be a good night. I think it's actually looking, the weather's actually picked up, so there's no doubt that we will get viewing. So it's going to be worth the effort, and if you read the flyer that came out, that gives you a list of activities that's going to happen. All right, let's move into the new members. If we can flash that up. Okay, maybe we'll do the live because let's do the live because Aaron, did you want to say something to the live? Must say it. Oh, that's only a very brief report.
I think there is an overview there which should come up. Just to finish to say, we've got a map of books and stuff on what you talk, two talks tonight on instrument, central conservation, and so a lot of the conservation there. And as you know, we're by far the largest astronomical society of Hubble, Exploring the Milky Way by David Myers, who got another one by him. What did you think of the light from Mars? That surprised me. And the American Sky and Telescope magazine, March, and the April Australian Sky and Telescope, there's an article on Captain James Cook. And what it read astronomy was how he used astronomy to do what he did. It's a read an article. At the end of the first one, there's a little brief section to point out that the Captain James Cook, that the captain of the first series of great courses of Star Trek was Captain James Kirk, and they named him after Cook. And there's a reason why they did that. I've never heard of it.
So where did the Tiberius come from?
It's on Star Trek 3. I was destroyed by that. But anyway, that's about it. There you are, so that's about it. Come to the library after me. I haven't announced after the meeting. When John and I were taking anybody to the library who wants to come to the library, then we'll go all the books. Something they're talking about, there's a massive books at the library on those sites.
Barry, did you mention there won't be one in...
Sorry, who's asking the question? Oh,
There's no meeting in April?
Sorry?
There's no meeting in April
oh,
after members' night.
because it's Good Friday, the library, and there's no members' night too on Good Friday, which is there won't be, we can't do that. And it's also the Friday, first day of the NAC conference in the parks, isn't it? So we can't do that. Okay, yeah, right.
Thanks, Barry. Just a reminder that we have a working meet up at LNDSS the following week after the start date. Sorry? 18th April. Oh, sorry, the following month, 18th April. So if you're wanting to go up and do some weight, get some sweat in there, so I'm sure they're going to be happy to result. And a free barbecue. And a free barbecue. Right? No. All right, bring your own. After the meeting, if it's clear, Rod and Linda will be opening up the Orange House to for viewing. So if you have time, please go over and have a look and see what's up. Finally, the new members. 29 new members have joined since the 12th of February. I'm not sure what our count is, but it's somewhere between 1,400 and 1,500. I still want to increase that 1,500 mark. We will.
We're fine.
All right, thank you. Any other announcements? If not, we'll move on in the program. Okay, good. I'd like to introduce Perry Lawless, our musician. You're not going to shout.
I will shout, so
You don't want to get the mic. Oh, that's very good. Okay, Perry's now going to yell and give you spoken up.
evening everyone. Yes, a bit of a bug. No, I'm not going to use it because it may infect someone. I've got a bit of a bug, but it's not the same symptoms as the bug. So, but don't want to pass it on to anyone, so I'll not use a microphone. It is the Messier Star Party, and it's been named the Messier after Messier, the Messier Star Party, because at this time of year there are an awful lot of Messier objects that are available to be viewed over the course of one evening. In fact, you can get about 80 or 90 of them in that one night if you really want to set your mind to it. There is well, it's not a competition as such, but the Messier 100 kit will help you identify and find all of the 100 objects that are visible from Victoria's latitude from Messier's catalogue. I'm sure up at the Star Party that some of those kids to hand out from the deep sky section. Less light here, Steve. Thank you. So let's go to the 14th, which is the Messier Star Party date. We're looking towards the west. Sunset is about 15 minutes or so, 20 minutes before 8 o'clock, and Venus will be in the northwest sky, so that'll be easily visible. Now, I've got a question. What is the brightest Messier object? Visible this time of year, sorry. M45 is correct. Russell, you know your stuff. And otherwise known as the Pleiades. So let's advance the time and see what happens. There we go, at about 8:30 or thereabouts, when sky for the night will begin at Heathcote. There's the Pleiades. And the weapon of choice for the Pleiades is either binoculars or a small telescope with a wide field, low magnification to get all of them in. Now, in Taurus, there's another Messier object, and of course, it's Messier 1, which is Crab Nebula. Now, the V of Taurus here, with Aldebaran making it stand out, has a horn going from the head to Alnath, and one here to Zeta Tauri. Just below Zeta Tauri is the Crab Nebula. Who's keeping count? 2. There we are. Doesn't look exactly like that. They could have afforded a better picture, I think, but maybe not. Anyway, that's where it is, and one of the things to look out for with the Crab Nebula visually is that it displays a sort of zigzag pattern when you look at it. That's what the gas appears to do visually. Now, a little bit higher, of course, there's a well-known object here. What is it? Well, that's the Horsehead Nebula Barrier is not a Messier object.
Oh, no.
The Orion Nebula right there, M42, but right next to it is also M43. Not to be confused with the Running Man Nebula, which is what I did recently, and Steve saved me. Thank you, Steve. I don't know what the hell I was smoking when I said that. But a little known nebula also in Orion, take a line through here, and about there you come to M78. Another gaseous nebula, which has a little bit of a ghostly feel to it. In fact, through a telescope, There we go. Now, in the same area and a little bit higher, there is a star which is part of the sort of shopping trolley shape of Orion there, and it is safe. Hardly anyone ever mentions poor little old safe, but it's a second magnitude star, quite bright, and it points the way to another Messier object. So if you take a line through safe and a straight line through these two stars of Lippus, the hare, takes you about there, and there's M79, a not often looked at globular cluster, but worth the trouble. Right there. Who's keeping count? 5, thank you. Right. Now, a little bit higher up, we've got Sirius and the big dog lying on its back. And right here, I don't know who comes up with these little names. I've never thought of it as the little beehive, but it is M41 in Canis Major. Beautiful little cluster, a bit like, not as an impressive version of the jewel box, I suppose. Now, there's Sirius, there's Wesson, which is the posterior of the big dog, and right here an isosceles triangle pointing down brings you to two clusters very close together here. One of them is M46 and one is M47. In fact, these two are pretty easy to find. You can see them with naked eye, but I'll centre them and we can have a little bit of a squeeze at them. M46 has a lot more bright stars. 47 has a lot more bright stars. M46, fewer but richer cluster. And also contains a fabulous planetary in there. You can just make it out in that position. So 2 for the price of 1. Further over, M93, we'll centre that. Another open cluster. Beautiful little thing. Whilst we're in this part of the sky, let me talk to you about this star. Here it's called HIP something, but most of us know it as H3145, which is a beautiful coloured double star, and you can see it just split into 2 there. The way to find it, take a straight line from the leg of the dog through the bum of the dog and extend it as far again, and you're in the right area. A little bit later in the evening, let's go north. And advance the time. Here, Castor and Pollux, and over here at the foot of Castor and Pollux is M35. We've looked at it before. We don't need to have another good look at it. Who's keeping count? How many?
101.
101, I wish. All right, let's move on a little bit. What's the next zodiacal constellation after Gemini?
What about 36 and 38? Just went past.
I did, but I pointed those out last time through not only 36 but also 37 and 38. Through here, it's a little bit later in the evening, but they're right through this section of Auriga. All right, let's keep moving. Oh, yes, gone too far. The beehive is in this area right here. Great binocular object. Small telescope object as well, it's a good one. But another little cluster that doesn't get much of a Guernsey. King Cobra? What the? As I said, I don't know who's been naming these things, but another beautiful little open cluster. Still in Cancer. Now, if we move over to Leo, this is Denebola, the tail of Leo, and between Iota and the star they call Shartan, but it's usually Epsilon, is the Leo trio. Oops. M65 and M66, easily visible there, two galaxies. What's the other one? Thank you, Steve. Not featured in this version of Starry Night. But now if we take another line from Iota through this end of Leo through to Regulus, about halfway, another couple of galaxies, M96 and M95. How many is that? 15. How much longer, Steve? 1 minute. Let's finish up with many people's favourite galaxy and then one more thing. Here is Corvus, the crow. Roughly, if you take a straight line from Minkar through Delta Corvi, which is Algorab, and a fabulous double, to about there, you get the Sombrero Galaxy. Let's zoom in. There it is. I like to call this asterism the little scorpion. There's the sombrero, and up here is the double triangle. Over here is a Struve double star, even magnitude, a beautiful thing. So there's quite a little bit of interest in this area. Finally, as we head towards the southeastern horizon at this time of the evening, we've got the Emu standing vertically, rising up out of the horizon. And when you see it at this time of year at about 10:30, it means that the scorpion is only about an hour away. So let's advance the time. Emu rises higher, the moon is coming up this weekend, and there's the head of the scorpion. There's Antares, of course, M4 is here, and the tail goes all the way to there with M7 there. How many is that? About 20? All right, 20 in about 10 minutes or so isn't a bad job. You could probably do that many live in person on Saturday night. I look forward to seeing you there, and thank you for your attention.
Thank you, Gary. I have a question for you all. If you had a go-to telescope where you enter your commands into the hand panel, and you had an experienced observer on a 10-inch Maxonium, and you gave the list of messy objects to find, who do you think would win? Just sort of show of hands if you think that the go-to telescope would be fastest. Sorry. Well, the visual observer beats the go-to scope every year. Alright? Well, you think about it. If you're smoothing the go-to scope, it takes some time to get from one part of the sky to the other. But if you're moving a Dobsonian, which has got a telemeter, you know your stuff, you can move it in a split second. Right? It's really simple. Okay, now that brings us to the first of our speakers tonight, which will be the issue making section. Hand over.
Yeah, use it.
Can everyone hear me? Or
If we don't have a mic, people watching the stream won't hear you.
so what would you prefer? I use the microphone?
Yeah, use the hand mic if you can.
Okay. Is it on? Can everyone hear me? Okay. Please tell me if I need to be loud or whatever. I'm not a school presenter. But anyway, my name is Mark Justice. I'm the section director of the instrument making section. I took it over a number of years ago when it was suggested that the instrument making section might disappear. And I got a lot of value out of the instrument making section. I didn't want it to disappear. So in the end I became the director. So here I am now. So, since then we've done probably a lot of other stuff in instrument making, and I'll just try and share that now. So excuse me as I review. So the instrument making section meets on the third Saturday of the month at Power Street between 2 and 5 p.m. Please come along. It's an interesting group of people. I suppose what I'm here to talk about tonight is what the instrument making section can do for you. So rather than going through how various things we're making work, I just want to go through them and show what we've been doing to try and see whether there's something that you think would interest you. I'm just trying to go through a collection of things to try and give you something that you might find. So now I'm going to walk you through some of the activities we've been up with. Your standard Dobsonian telescope that I think ASV recommends, your standard 8-inch Dob. Now this is not quite a standard 8-inch Dob up here, but it's a commercial tube in one of my wooden boxes. And these tubes, or the commercial 8-inch Dobs, are fantastic value, and they do a great job. But I always like them, or I dislike them because you have to keep nudging them to track stars. Now I'm a bit of a keen planetary person, and I like high magnifications, and I like the telescope to move with the stars. So in this case here, we've got down the bottom here of the scope, we've got termed the tracking platform. So this platform will move and cause your telescope to follow the movement of the stars. Actually, this sort of thing works brilliantly at astronomy for the people, because just set your job up and it will run for, you don't have to touch it for 10 minutes or more, or maybe longer. So, anyway, we decided that instrumenting section we get together and build some of these. So there it is. There's one of them underneath the scope here. And here's a bit of a picture of it, and you can see that there's an arc on the bottom. And if you can see it here, it's simply the telescope sitting on top. This thing is pivoting along, and the axis of this is actually parallel to the Earth's axis, so this counteracts the movement of, or the rotation of the Earth and the movement of the stars. And it's only made of timber and a few bits and pieces. You can see the green bits, the rollers that the top sectors move on. I've got the one out the front here, and there's another one out the back, and we'll be more than happy to explain it to you after the talk. So please, there's a fair bit of stuff out the back to have a look at. So we've built more than 15 of these, or I think it's actually close to 20 of these kicking around various things. There's been two versions of them. There's the one here, the timber one, which was 8-inch scopes. And the last build, got an example of Paul Gardner's version is up the back. I think he puts an 8-inch scope on that, and people put 12s on them as well. So we've got the small one that's shown here, and if you have a look at the black one up the back, that's one of the bigger scopes. Here's the baseboard with a couple of shafts and rollers and stuff on it. You can see this little motor here. This drives these green rollers and drives that arc to attract the movement of the stars. You'll note that all these green bits here, this bit, the rollers, the motor mount and stuff, are 3D printed. So we do need a bit of 3D printing and instrument making. If you've got a 3D printer and maybe not having much luck, or you've got some 3D thing you'd like printed that you've got the design for, maybe something of Thingiverse. Actually, Rod, who's up the back, brought me an example of something to print the other day, and it's for his testing of mirrors. So he's up the back for you to have a look at. This is just an example of the motor mounting bracket that was on the platform. I use a package called FreeCAD, which strangely enough is free. And you can see it does quite a good job. The rollers and the bracket, and this is it drawn up. I like it because I can draw it up and then make simple changes. It's not hard to print again, whereas I'm machining something on a lathe or a mill and I muck it up. It's a pain to have to go back and do it all again. But it's worked very well for our platforms. So. The ASV is trying to be inclusive of people of all abilities. And one thing was talked about including visually impaired people. And Chris Rudge approached me after he visited some other people, and he asked me whether I could print a 3D star chart. So this is Scorpius here, where the different brightness stars are represented by different height and size peaks. So someone who's visually impaired can run your fingers over this and get a feel for what Scorpius looks like. So as I said, this is part of ASV, trying to include everyone and provide things and maybe wheelchair access and stuff up to deep it and things like that. So anyway, I've printed Scorpius. It's just something like this, and come have a look. And as it has to be, Brian is up the back on the opposite side of the sky. On these platforms, you need electronics to drive the motors. And we use Arduino boards, which is this board here. Some of you are into telescope controllers and making your own stuff, might have built that sort of stuff. Anyway, so we use Arduino as our base computing element, and then we did some custom electronics here. And we have members assembling these boards. We had them lined up with soldering irons and loading bits, and everyone had great fun putting them together. So this is a custom board for our platforms. I know there's almost 20 platforms, but we made 20 of month left, I think. So we should just go back to platforms. We may make some more platforms in the future, but for the moment we're going to move on to a few other things. I don't want to spend forever making platforms, but if you're interested in making a platform, come along. If there's enough people interested again, we may push forward with another build. Something else we played with a bit, and there was a member, Sky Murphy, who was pretty regular instrument making and still comes from time to time, and she was pushing spectroscopy. And I suppose from that, we started to consider building a Prism Spectrograph, and Barry Adcock had some ideas here and came and presented that we've got this optical glass at Harvard Street, let's try and make something out of it. So just to go back a bit, I just wanted to say, this gamma valorum, this is the spectra, so you can see the yellow, blue, red lines here, whereas Sirius has almost a continuous spectra. So the stars can be very different. And I suppose when we look visually, we're only looking at part of it. We probably do notice colour, but I suspect a lot of people don't look at the colour of the stars very much. So anyway, everyone knows, which is this technically incorrect picture, but anyway, that you take the prism to split the colour, white light into its colour. If I go back there, you'll note that the light comes in here and then goes off at an angle here. So what we've done in this arrangement for our prism spectrograph is we've got three prisms, they're actually different glass. You can see white light comes in as a continual out here that's all on axis. So we can take this prism and put it at the eyepiece of our telescope and look through it. And some of you may know E.J. Harton, the famous Australian observer, Melbourne observer from Mansfield, and he used to, in his book, if you go through it, talks a lot about using the Prism Spectrograph, like this, a prism, to look. Mainly he uses it to look for planetary nebula, because they'll have line emission, whereas lots of other things will be continuous emission. So he'll look for that using the very few prism. So I'll just move through reasonably quickly. So we got some glass, we cut it up, roughed it out, trued it up, and then we went through a polishing process where they were blocked up, and Barry Adcock has helped us a lot there. And then we end up gluing our three pieces of glass together here, and it's mounted in a frame that you can look through. I haven't done a lot with them yet, but we had some problems with the gluing process, and Frank Marion has put a lot of effort in, and we just need a nice sunny day for our UV pure adhesive. So hopefully next month with instrument making we'll get some gluing together. The big thing that people talk about, I suppose, in telescope making is mirror making. And I think years ago there was lots and lots of mirror making, and then mirror making died away, and there wasn't actually much of it happening at the instrument making section. But for reasons I don't totally understand, or maybe it's just providing people with bits of glass and grid easily, we've had a lot of people over the last couple of years making mirrors. And I just wanted to go through some of those people and what they've done. So this is people in the last couple of years who've been making mirrors. And I'll just start at the top. Logan. This is Logan here, very early on when he came to instrument making. I think we gave him some grid, a couple of bits of glass, and strapped it on a box of wood and said, go for it. And away he went. We started with a 10-inch mirror, which I thought was maybe a bit big, but it was keen as mustard, so off he went. He completed the mirror, did a great job, went on to make another 10-inch, and then a 6-inch mirror, and now he's working on a big mirror, a 16-inch mirror. But he's causing him some grief, but it's a really difficult project to undertook. Swing is another teenager. He's hoping to be here tonight, but he's not. He's working on an 8-inch mirror. Beth is a retired lady and her husband Bruce. She joined the society and went to her first barbecue, and she won a 12-inch Dobsonian there. We had a second-hand one, and I think area suggested we can make it a price. So she won that, which is fantastic. And then she went on to make a platform, put the telescope on, and instrument making, and now we sort of said, how about you make a mirror? So she is, and she's in the polishing stage of that mirror now. Kevin just recently retired, maybe 12 months ago, started a teenage. Aaron, another teenager, he came in and blitzed it and made the 8-inch mirror and did a fantastic job with it. Paul, retired gentleman, years ago, started to make a telescope in his teens and didn't get there. The glass went somewhere, so he came back and said, I want to make one now and do what I didn't do years ago. And he completed May, now making a 6-inch fast mirror. David is making a 10-inch, just had a new baby, so he's a bit busy at present. Jim is Jim Muller, who's a regular up at Ingot. He's made quite a few mirrors over the years, and somewhere along the way I had a piece of 6-inch glass or something, so we had to make a mirror out of it. Rod Brackenridge is up the back, is currently working on an 8-inch mirror. It's quite fast, over actually F3, 3.1. He did start some time ago, he's made many mirrors over the years. All these people are reasonably regular instrument making and incredibly keen to share their knowledge. Stephen Buddha, he's just heaps of mirrors, and me, I've got a few bits of glass I've never quite finished. I'd like to finish the 14-inch mirror that I started years ago. I'll just quickly, this is Sweeney, who I mentioned. This is early on, we got him a 44 drum with a couple of bits of glass and grid started grinding. Here he is, telling him I'm polishing inside the club room. But polishing has to be clean, so we've had a few extra sessions, but mirror making is not easy. It takes a big commitment of time and thought and care, but you can see it can be done. There's sort of guys there pushing glass by hand, but you can use machines. And we've got these two machines at Park. This is a big spindle, vaguely capable of doing half-metre diameter mirrors. I did some repairs on it after we got it and that, and I did run it for a bit. Here it is with my 14-inch mirror that I mentioned. So the mirrors, the green plate glass on the bottom, and then there's a polishing tool on top, and you can see the polishing compounds sort of splash around everywhere. I want to get back to this, but it did a good job smoothing up the mirror a bit. But this is there, and if people wanted to make a mirror or keen to maybe use a machine, there's no reason with a bit of training we could let them loose on this. It's there to be used.
How long would it take?
How long is a piece of string? People can knock up mirrors, make a 6-inch mirror in a week, or it might take them a year. It just depends on how good you are, or how careful, how lucky you are, maybe how much guidance you've got. There's a lot of skilled people at instrument making who can give you some guidance. It's a bit hard because instrument making is once a month, and almost mirror making calls for more meetings with just a bit more focused help. And we've done that a couple of times, but maybe we need to think it through a bit more. But people are successfully making mirrors nowadays. So once you've made a mirror, you've got to make it telescope. So this is Sweeney's 10-inch mirror mounted, and there's another, that's his old mount here, and he just recently remade it into this one, which moves around apparently a lot better. I haven't seen through it yet. So so-called truss tube. Sweeney, he's made this top octagonal tube. I said hexagonal somewhere, but it is octagonal. This is the top for his truss tube and the spider assembly. This is last month of instrument making. Rod is the expert on the nice tube work up there, and Rod can show how he glues them up and how he cuts them on his saw bench. put them and adjust them, put them together and adjust them, and they start to appreciate what a good telescope can do. So I think if you make your own, you'll appreciate it, because lots of people sort of buy a commercial Dobsonian telescope, and if you don't collimate and do other things, you don't get great performance out of it. So what, sort of leading on to something here. The instrument making section has a base group of people who come along every month, and then there's sort of a slightly more transient people who come along as they want to make something and then move on. But some of the activities that we've done in the instrument making that have been the most fun have been the group projects. I mean, some of the days when we've been platforms and there's been the backyard full of people and saw benches and everyone making stuff. I think, Barry, you would agree some of those busy days are pretty impressive.
Yeah.
So the group projects where we can all get in and help each other work really well, and they're good fun. So what we're thinking of doing is offering to members if they'd like to make a telescope, but I'm not suggesting that they make the mirror. I'm suggesting we buy commercial mirrors, commercial mirror set, and then you make a telescope. And the sort of thing we're suggesting is one of the timber tubes, something like this. So we make an octagonal wooden tube, we make a spider, a mirror cell, a helical focuser. That's not a helical focuser, but we make one ourselves as an example of spider, tube, helical focuser up the back you're going to look at. And we would make, probably with 3D printing, make up a Telrad type finder, but make our own. We'll be Dobsonian mounted, zero expense required, very approximately $475. So I'm just tabling this. If I get enough interested people, we might do a group build of, say, 10 telescopes. So I think that is all. So if you're interested in making a telescope, something like this, see me or right up the back, and we'll take it from there. So I hope that gives you a bit of an idea of what we get up to in instrument making, and please come along if you just want to come 1 month and have a bit of a look. What we do at 2:30, we sort of go around the room and each person who's there will explain what they're working on, and that gives other people an idea of what's happening. So please come along to an instrument making section. Everyone is welcome. You don't have to make a booking, just log in whatever time, somewhere between 2 and 5. It's good to come in for the 2:30 round the room so you can get a feel for what we're doing. And I'll close just by thanking lots of people like Barry Adcock, Rod Brackenridge, Frank Marion, there's probably a whole lot of others. Stephen Buddha is always there to help, and there's a whole lot of other guys. And I mean, I know Paul Gardner's sitting over here and he's made a platform and he helped heaps when we were making our platform. So thank you to everyone who helped, and I encourage everyone to come along to instrument making. Thank you.
Thanks, Mark.
That's better.
Next up will be the section director for solar.
Thanks very much. That's all right. Spare your applause to the end. Oh, here we go. Excellent.
Do you want a microphone?
Yes, please. Thanks. I think I might turn it around this direction as well. I guess it can work from each side. Well, whilst we get some up, thanks very, very much for coming along tonight. I don't like being in the limelight. Whoops, there we go. God, I thought I had pretty good night vision as well, but I'm bumping into things. That's probably why I'm sole section director. I do all my astronomy during the daytime, so I don't trip over things. Anyway. Just loading up. Well, solar section, we've got, as Mark said, there tends to be a hardcore of members who come along each Sunday, but I think we'll say in general we have about a dozen to 16 who come along, and more come along if there's an event of special interest. Please, I have it on three machines, and they don't like it to be on any more than 2, so I'm not stealing Microsoft's property. Right. Here we go, solar section. Well, in fact, my history is a little bit like Mark's. That 2013 came along, and the solar section director had moved out of Melbourne and wasn't able to come along to meetings, and the section was in abeyance. And because I was so keen on Aurora, I thought, well, that's to do with the sun, so I put my hand up to be solar section director, and it's been a lot of fun. I have learned so much in being director, so please do not be afraid of taking on a little bit of responsibility like that. So, we meet monthly, as you can see there, excepting for January and December, on the last Sunday of the month at Melbourne Observatory, brackets MO. And meeting at Melbourne Observatory provides several benefits actually. We can gather in the ASV library at 1:50 for a 2 o'clock start, and gives visitors an opportunity to have a look, see the library, to see what goodies the library has, and also to see some of Melbourne Observatory's main building, dating back to 1863. Also, it gives us the opportunity of using the 3 Melbourne Observatory historic telescopes for our meetings, which is a real great plus. Sorry? All right, okay, yep, here. Now, the solar section has 4 objectives to each enjoy in turn. And the first one is safe solar viewing, and I'll be just summarising what we do and then go into a little bit more detail. Understanding the sun and its behaviour. The sun is our nearest star. Wow. And through observing the sun and using the data that billions of dollars of satellites, etc., send out on the planet, we can have that opportunity of understanding the sun and try to understand why it behaves the way it does. We also enjoy how the sun impacts the Earth's space environment. And also solar-related phenomena. So let's have a look at the first one, safe solar viewing. So please bear in mind the sun is extremely dangerous to observe without appropriate protection. So don't, and I'm sure you all know that, but don't stare at the sun during an eclipse or during daytime. Please don't use a telescope to look at the sun or binoculars. You risk suffering permanent eye damage, unless the equipment is specially designed for safe solar viewing. So an important part of the solar section is to educate about safe solar viewing, and that's what we do. Now, from time to time, we'll see a collection of these black spots on the sun, which we, of course, know to be sunspots. And the number of sunspots we see can vary dramatically from month to month, year to year. And that's an important thing to know. Why do these numbers of sunspots vary so much? This image also was taken through a filter which we call a white light filter. And every 2 years or so, we have a workshop either at Melbourne Observatory or at the lodge where we make a white light filter. All materials are supplied, and that's when we have up to 24 or 28 people who come along so that they can build their own white light filters for safe viewing of the sun. Now these filters, and I have some binoculars here which I'll show you later on, has a pair of white light filters over the front of them for safe solar viewing. And these were made at one of our workshops. So please, next time I send out an invitation for a workshop to make a white light solar filter that goes over the front of your objective, whether it's a refractor, binoculars or a reflecting telescope, please come along. Of course, you're welcome to come along anytime you like. And here's our beautiful 4-inch lunt hydrogen alpha solar telescope set up at the back of the main building at Melbourne Observatory. And a fine collection of people there enjoying looking at our beautiful star, the sun. Now, safe observing not only applies to visual observing, but also the use of cameras, etc., to actually record the sun. And all meetings, all members or attendees are invited to bring along something to show and tell. I just love showing and telling, don't you, Barry? Yeah, just love it. And everyone is encouraged. It's not essential to come along and bring something, but we do encourage those to bring along. And Arthur Coombs, who's not here tonight, is a wonderful contributor to the solar section with his images. So here's a couple of images that Arthur took. As you can see, hydrogen alpha. The one on the left-hand side is taken through a monochrome camera, so it's recording hydrogen alpha wavelength in the red, but only recording grayscale. And on the right-hand side, Arthur has taken a picture of some beautiful prominences on the limb of the sun in monochrome, but has added some yellow colour afterwards. But these are typical things that you would like to see through a hydrogen alpha solar telescope. And we do see them. We make use of the photoheliograph at Melbourne Observatory. It has been modified for safe viewing using in hydrogen alpha. Here's a picture of Martin Jones and his daughter having a look through the photoheliograph at the sun one day a few years ago. Bearing in mind this telescope was built there in 1874. So what a wonderful privilege it is to have a look through a telescope which is getting into 150 years old, looking at our sun through it. And this is what you might expect to see through a hydrogen alpha solar telescope. This feature is called a filament. The sun being so large, one tends to lose the proportions here, but that filament is about half a million kilometres long. Remember, our Earth is only a measly 14,000 kilometres in diameter. This is 500,000 kilometres long. And with all that modelling and the filament and all that structure, that is true structure in that layer of the sun which we call the chromosphere, readily visible through a hydrogen alpha telescope. So the second telescope that we have, we can put a white light filter over the front of it and have a look at sunspots faculae. That's the 12-inch reflecting telescope. The 8-inch refracting telescope, the Troughton and Sims telescope, a spectroscope, very similar to the one that Mark mentioned, can be put onto that telescope so we can observe the solar spectrum. So that takes direct sunlight into the telescope through a fine slit, through a spectroscope which splits the sun's light into a large rainbow, and you'll see with your own eyes a number of, well, hundreds of dark lines cutting the colours as we see here. And each of those lines, as we can see represented there, represents an element, a chemical element that's present in the sun's atmosphere. And you can see these with your own eyes. I'd also like to point out two lines which are indicated as O2. They're not oxygen or O2 in the sun, but they are due to oxygen in our atmosphere. So because of the sun's brilliant light, we're actually able to see some pretty rare and faint and weak absorption lines due to oxygen in our atmosphere. Once again, with your very own eyes. Now, we might have a look at the spectroscope and the sun solar spectrum probably 2 or 3 times a year, but nevertheless, it is a fascinating thing to behold with your own eyes. Key part of our meetings, well, an observation is a key part. In fact, if it's a clear Sunday, we might spend an hour or hour and more of our 2 hours just looking at the sun and enjoying it. If it's cloudy or perhaps it's not that much to view on the sun, we generally have a short presentation made by myself about solar behaviour, solar activity, stuff like that. So here's an image of the sun taken through the ASV's hydrogen alpha solar telescope, perhaps a month or so ago. One little sunspot just there. So where are all those big sunspots gone? So that image in white light was taken during a period we would call solar maximum, where the sun's activities are maximum, and we can measure that by the number of sunspots that we see. A sun with only one sunspot, or none, is a time of sunspot or solar minimum. However, look at all that fine structure on the sun, and there will be a few prominences around the edge as well, very, very faint. Don't come up very, very well here at all, but it is a truly beautiful view through the solar telescope. There was a German in 1843 who, looking at the rise and fall of sunspots on the sun, recognised that it was actually a cycle, a solar cycle of about 11 years. And that's represented in this plot here. That tells us a lot about solar activity. Why does the sun have an 11-year cycle? We don't know. It's down to internal workings. But the more stars that we observe, the more we realise that other stars have magnetic cycles like the sun as well. So the sun is not unusual in having a magnetic cycle that we see here. So that's another feature of our meetings, examining solar activity, because that has an important impact on life here on Earth. Okay, this might be a little bit, it's a beautiful picture, but I won't go into much detail, but come to solar meetings and you'll learn a little bit about what this picture means. All it means is that sunspots change their position on going from solar minimum to solar maximum. They approach the equator of the sun. What about the Sun-Earth environment? Come on. While I'm mentioning about the Hydrogen Alpha solar telescope that ASV has, we actually have a smaller version available for loan. So if you'd like to have a free use of that solar telescope, please come along to some meetings, get to know how to use it, and you can have a free loan of that Hydrogen Alpha solar telescope for up to 3 months and use it yourself. Now, a lot of the information we have about the sun is because of probes that are currently operating in orbit around the sun or around the Earth. And I'll just let this go through. It's quite a lot of them. I'll just do that. Sorry, a bit quick. Oh, bother. Quick scroll through. 8 or 9 or more probes are currently providing information about the sun. There we are. There's 5 there. Launched from 1994 onwards. And some of the more recent ones. You might ask, well, crikey, the sun's getting a lot of attention, isn't it? With all these satellites up there, monitoring the sun, monitoring different aspects of it. The reason is because the sun is dangerous. It is dangerous to our technology here on Earth. There's a feature related to the sun called space weather. And space weather in space can be very damaging to orbiting satellites, can be dangerous to our electrical supplies here on Earth. And that's why it's extremely important for all these probes to be constantly watching the sun. And those probes send data down which we utilise and make sense of. So here I have a video that I produced from these billion-dollar satellites that are up in space. They send down still images. You can go to on the web to a program that allows you to access that data, put it together and make a video out of it. Maybe not. Sorry about that. Should be a little... Don't think that's going to happen. Should be a little play thing on this. That's a shame. End of presentation. No, joke. Right. This worked at home.
No internet.
Doesn't need the internet. No, it's remote. Bother. Here, I'll just have.
Oh. It animated.
There we go.
Yeah.
Ah. So this is about maybe 2 months of solar data for those big sunspots just appear out of nowhere. I think we should play that again. What do you reckon? Feeling lucky? No. Anyway, you saw some big sunspots there. That was 2003. Probably the most active month we've had for the last 20 years or so.
Do it again.
I'm trying to, Barry.
It's rather quick, so it's worth seeing it again.
Absolutely. Will it work though? Just watch these big sunspots. And that patch just opened up. That is a sign of solar activity. Lots of magnetic energy just waiting to be unleashed to cause explosions on the sun. So here's the sun in a different light. So this is one of the satellites up in space, which is now, that previous one was a white light image. Now we have an image taken in the ultraviolet. And just watch the sun bristling with activity. Start again. No, bother. Just say those magic words, Barry. Say those magic words. Oh! This is about, 2.5 months of images put together into a video. Look at all that bristling activity. All those hot spots are flares on the sun, explosions that are blasting stuff into space. And videos like this are a centerpiece of our enjoyment in the solar section, and just enjoyment of all those billions of dollars of hardware up in space, sending down these images for us to enjoy. And we can see more. There's a probe called SOHO, which is the Solar and Heliospheric Observatory. It's constantly looking at the sun, and I've shown these before, but hopefully it'll work. Here we go. So what we're seeing here is the outer atmosphere of the sun, the coronal streams, and every now and again you see a little puff go into space. That's called the coronal mass ejection. So that's a blast, explosion on the sun, sending solar stuff into space, right out into the solar system and beyond. Ooh.
Coronavirus.
Just about. Very topical, Robert. Thank you. There's the planet Mercury passing through.
Wow.
This is 2003. Billions of tons of solar stuff getting blasted into space. And there we are. The detector was just completely a direct impact on the detector. So it's information like this that helps us, the solar section, to understand what the sun is all about, why it behaves the way it does. And of course it's probes like this that help scientists on the Earth, at least gives scientists on the Earth a few hours of warning that one of these big solar storms is heading towards the Earth, and so they can make their satellites safe and make electrical supplies, systems on the Earth safe from overload. Because it's happened in the past and it could happen again. Another beauty. There's no planet Earth on here, but I would estimate that planet Earth would be a little spot like this. 109 Earths will fit across the diameter of the Sun. idea what that is. Oh yeah. Did you just turn that down? I didn't mean the sound to come on. How do you... Sorry about that, folks. I didn't know there was sound with this.
Oh yeah.
Here we go. So this is over 6 hours, folks. Thanks, Robert. So that's another important aspect of solar section meetings, just enjoying all this, the power of the sun. It is quite phenomenal. So this is information that other satellites sent to us, and this is really just an overview, but we can make sense of all these spiky things. You know, the red lines going up, that's indications of explosions on the sun. From sunspots, if those sunspots are directed towards the Earth, that means one of these big blasts of solar stuff is going to pass by the Earth and perhaps cause mayhem. There's another measurement, solar wind it's called. Learn what all this information means from time to time at solar section. Then a plot here which indicates how much the sun's activity up in space is affecting the Earth's magnetic environment. Red is very, very good for one particular reason. Now, if all that stuff is too much for you, then just go to the internet and call up an aurora forecast page, which will put all this information into some sexy little dials like this. Red is very, very good for aurorae, like that. Because how many of you have seen an aurora australis or borealis? Not many. I think it's, is it something that's on your bucket list, those who haven't seen one? Yep. Very good. That's the sort of information you need in order to be in the right place at the right time. How do we know what's a good place? Well, see here, here's the auroral oval. It's basically stationary as the Earth rotates under it. And here's Tasmania and South Island, New Zealand. If a solar storm passes by, that causes the auroral oval to expand and contain more energy. And that auroral oval can actually cover, or can extend to southern Tasmania, southern New Zealand. But because this is occurring 100 or 200 kilometres or more up, even though you might think that elevation is very, very good, we can still see over the horizon and see this behaviour occurring so far up. So what does all this lead to? It leads to displays of the aurorae. Once again, simply down to the effects of the sun on the Earth's environment. And I just love showing, we love showing pictures of aurorae at our solar section meetings. Even during times of solar minimum, there are people are seeing aurorae in Alaska and Norway and northern Canada. Even Tasmania. I love this shot because of the Large Magellanic Cloud, and there's the coal sack over the tree and the auroral beams. It is possible to see aurorae in Melbourne. Here's one in March 2015. Single shots at Ricketts Point, added together. It's a bit clunky. You see the auroral colours, the greens, you'll see some reds. It's Ricketts Point, folks. You see, ironically, as the clouds tend to disperse, so does the aurora. There's no relationship there. It's just bad luck. But anyway, so aurorae are visible from Melbourne. And that's an aspect of the solar section discussions that I very much try to get across. So what about solar-related phenomena? Well, we have solar eclipses. It's very important for people to know when the solar eclipses are going to occur and if they're even marginally visible from Melbourne or elsewhere on the planet. Of course, these are the best solar eclipses, total solar eclipses, and a group of half a dozen of ASV members, we met up in Denver, Colorado to see this total solar eclipse in Wyoming in August 2017. How do rainbows occur? We tend to think of rainbows as being common, but really we may see a rainbow only a handful of times a year. They're not that common. But it's only because of the intense sunlight from the sun shining through water droplets that makes rainbows visible. Another solar-related issue. When there's a high cloud up in the sky, you may see a solar arc. Please don't look at the sun directly as I did with taking this photo. Try and hide the sun behind something, a tree or whatever, so you're not looking directly at the sun, because that can hurt your eyes. But you'll see a solar halo caused by small ice crystals up in the upper atmosphere. Also, you see around the inside edge a little bit of reddish colour, a little bit of a rainbow. And then from time to time, we'll see features called sundogs. Here we are. Sundog here, sundog there, 22 degrees, and a super zenithal arc, a little bit of the solar halo there. That was taken at Elwood. It's all about educating people to keep looking up. Lots of things are happening even in broad daylight that are of interest. And then fairly rarely are these almost iridescent clouds. Hopefully you can see the colours there. Some greens and purples and reds. Just there, these tend to be rather close to the sun. But if you've got a pair of Polaroid sunglasses or whatever, you'll see these colours very, very clearly indeed. Just keep looking up. So that comes to the next solar section meeting. I hope a few of you can come along. It'll be on the Sunday the 29th of March, Melbourne Observatory. The topic, nominally solar eclipses. If the day is clear, we'll be spending quite a bit of time looking at the sun and enjoying it. And if you need any further information, there's my email address, solar@asv.org.au. And I thank you very, very, very much for your attention. Thank you. Mr. President, Barry would like to ask a question. Is that possible?
I'm just about to ask questions. Mark, Russ, thank you very much for that. If you're interested, please go along to the sections. That's where the activity in the society resides, the bulk of it. And I think Russell's going to be up at the Messier Star Party with the ASV solar telescope, so you should be able to look at the sun in Hazel. Now, I was going to open up for questions, but what I'm thinking of doing is perhaps split we'll break this up and we'll split the audience or the section directors. Russell, you might want to be up the front here somewhere. And Mark, if you want to go down the back with the rest of the stuff. Those who are interested in either section could just go along and ask your questions there over supper. So we're going to now break for supper.